This is Mr. Martin, and these are the video notes for Geometry Honors, section 10.7. We're going to be talking about inscribed and circumscribed polygons. So when you're talking about inscribed and circumscribed, really, it depends on your frame of reference. So when you have a picture, you're going to have something that's inscribed and you're going to have something that's circumscribed. So let's go ahead and take a look at the two definitions. If a polygon is inscribed in a circle, then all its vertices are on the circle. So you notice in figure 1 here, this pentagon has all its vertices, A, D, C, F, and E are on the circle, so the polygon is inscribed in the circle. Now, if a polygon is circumscribed about a circle, then all its sides are tangent to the circle. So a little bit different. Let's look at figure 2. You can see points H, I, J, K, and L. Those points are all points of tangency or points of contact. So the polygon is inscribed or circumscribed about the circle. So if you look at the note here, it says a circle can also be inscribed in a polygon or circumscribed about a polygon. So in figure 1, the circle is outside, so it's circumscribed about the polygon. Okay, and in figure 2, the circle is inside, it's inscribed in the polygon. So again, it's point of reference. So depending on, if again going back to figure 1, if we're talking about the polygon, it's inscribed. If we're talking about the circle, it's circumscribed. So make sure you're very specific about which figure you're talking about. So the circumcenter would be the center of the circle circumscribed about a polygon. So this would be point B in figure 1. And then the incenter is the center of the circle inscribed in a polygon. So in figure 2, the circle is inscribed. So that incenter would be point G. All right, so that takes care of our definitions. Let's take a look at a quick example here. And we've actually done stuff like this before, so hopefully this isn't brand new for you. We've got A, B, C, D is inscribed in the circle. And we want to show that A and C, one pair of opposite angles, are supplementary, and then B and D are also supplementary. So since A is an inscribed angle, I know that the measure of angle A is going to be 1/2 of arc BCD. And I also know that the measure of angle C is going to be half of its intercepted arc, so it's going to be half of arc BAD. So if I add up these two angles, I'm going to have the measure of angle A plus the measure of angle C is equal to 1/2 BCD arc plus 1/2 of arc BAD. And I'm going to factor that 1/2 out, so I get 1/2 of BCD plus arc BAD. All right, and if we look at arc BCD and arc BAD, you notice that if I put those two arcs together, it's going to make the whole circle, so that's going to be equal to 360. So that means that the measure of angle A plus the measure of angle C is going to be 1/2 of 360. Because again, let me highlight this, these two arcs together equal 360 degrees. Okay, and then half of 360 is 180 degrees. All right, therefore, since the sum of those is 180, we know that angle A is supplementary to angle C. If we needed a reason for that, we'd say if the sum of two angles is 180, then they are supplementary. So why don't you go ahead and pause the video and see if you can write out a similar proof for angle B and angle D. And then when you're finished with that, you can go ahead and restart the video and continue with the notes. And then once you do finish that, if you have questions, make sure you ask me in class. All right, so moving on to Theorem 93, If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So that's a direct um, result of this example that we just did here. This example, we basically proved Theorem 93. So if I have a circle, and what if the quadrilateral is a parallelogram? So if I'm going to draw a parallelogram in here, and it has to be inscribed, so I know that the opposite angles are going to be parallel, and these opposite angles are going to be parallel, and all the vertices have to be on the circle. Let's use your imagination. My picture's a little bit off. Then what has to be true about this parallelogram? Well, you can probably see in the picture the parallelogram must be a rectangle. Okay, so keep that in mind. If you know that you have a parallelogram and it's inscribed in a circle, then you know it has to be a rectangle. Okay, so that gives us Theorem 94. If a parallelogram is inscribed in a circle, then it is a rectangle. Okay, and the nice thing about a rectangle, when we inscribe it in a circle, other important conclusions that follow from Theorem 94, the diagonals of an inscribed rectangle are also diameters. Okay, and then don't forget about the Pythagorean theorem, because if I have a rectangle, we know that all these angles going back up here are going to be right angles. So when I draw in this diagonal and it goes through the center, I've got right angles. And we know that the diagonals of the rectangle will meet at the center of the circle. So if I draw in the other diagonal up here, we know that these diagonals are going to go through the center. All right, so let's take a look at a quick example. I've got that ST is 5, I've got that TU is 12, I've got that UV is 9, and I also know that STU is 90 degrees. Okay, and we like that this is 90 degrees because now we have a right angle inscribed in a circle, so it has to be inscribed in the semicircle, which means that if I draw in this segment that connects S and U, I know it's going to have to go through the center, because if I can inscribe a right angle in a circle, again, it's got to be inscribed in a semicircle. So now I can easily see that SU is going to be 13. SU equals 13 because it's a 5, 12, 13 triple. And again, if you don't remember that triple, you just use Pythagorean theorem. And now that I know that this is 13, I can find SV. Again, since this is a diameter, I know that this angle is inscribed in a semicircle, so that's going to be a right angle. And I can use Pythagorean theorem. SV squared plus 9 squared is equal to 13 squared. So SV squared plus 81 is equal to 169. SV squared is equal to 87, which means that SV is equal to the square root of 87. And that's it. So if you have any questions, make sure you write them down and ask me. And we'll see you next time.